Hello students, now we are going to discuss about potentiometer. First we will see the working principle of this potentiometer. The working of potentiometer is based on the fact that the fall of potential means potential drop across any portion of the wire is directly proportional to the length. So I am taking the potential drop V is proportional to the length L. Or else if I remove the proportional element constant V equal to pi L. So where pi is the potential drop per unit length, pi equal to V by L. So fall of potential across any portion of the wire is directly proportional to length. Now based on this principle, we will compare the EMF of the two cells as well as we can find the internal resistance of the given primary cell. This is the circuit diagram representing potentiometer. It will have the primary circuit and secondary circuit. In primary circuit, we have battery of EMF E and plug key K and rheostat. In secondary circuit, we will connect the two cells whose EMF are to be determined. Cells whose EMF are connected in the secondary circuit by closing the key. So to compare the EMF of the cells, how do we compare the EMF of the cells? We will see here. By closing the key K, the constant current is provided to this potentiometer. Then first K1, so here we have the two keys K1 and K2. The first K1 is closed and K2 is open. If I close K1, cell E1 is included in the circuit. By closing first K1 is closed and K2 is open, the current flows through the cell E1, because when I connect this K1, current flows through this cell E1. Then a galvanometer shows some deflection. When the current flows through it, a galvanometer shows some deflection. The position of jockey is adjusted for the null deflection. The position of jockey is adjusted to note the balancing length. We will get the balancing length when the galvanometer current is 0. So when the current flows through the galvanometer, it shows deflection. We need to make the deflection 0 by adjusting the length of this jockey. The potential across any length of the wire is directly proportional to length. So the cell is having the EMF E1. E1 is proportional to length L1. If I remove the proportionality, I will put on constant of pi L1, epsilon 1 equal to pi L1. Now what we need to do? Now the K2 is closed and K1 is opened. K1 is opened. When K2 is closed and K1 is opened, the cell E2 is included in the circuit, current flows through it, then galvanometer shows some deflection. The position of the jockey is adjusted to note the balancing length, that is epsilon 2 is proportional to L2 or epsilon 2 equal to pi L2. So if you want, you can change this K1 E1 here, K1 K2, just interchange the terms. K2 is closed and K1 is opened, epsilon 2 is included in the circuit, galvanometer shows some deflection, adjust the position of the jockey to get the null deflection, then note the balancing length, epsilon 2 is proportional to L2 or epsilon 2 equal to pi L2. So this is equation 1 and this is equation 2. So by dividing equation 1 by equation 2, we will get epsilon 1 by epsilon 2 is equal to L1 by L2. So by using this equation, we can compare EMF of given two cells using potentiometer. Now we will find the internal resistance of a given primary cell. To find it, first we will connect the cell whose internal resistance is to be measured if connected in the secondary circuit across the resistance box in parallel. By closing the key, a constant current flows. By closing this key, constant current flows through the potentiometer. First, the key K1 is closed and K2 is open. When we close K1, the cell of EMF E is included in the circuit. Current passes through the cell E and the galvanometer shows some deflection. So the position of the jockey is adjusted to note the balancing length. So when I close the key K1, current is flowing through this cell of internal resistance R. Galvanometer shows some deflection. The position of this jockey is adjusted to note the balancing length. Means for the null deflection, we are adjusting the jockey. The balancing length is noted, so epsilon is proportional to L1 or epsilon equal to pi L1. Now K2 is closed. This K2 is closed and K1 is opened. This resistance box is included in the circuit. Now the position of the jockey is adjusted to note the balancing length. So potential difference V is proportional to length L2 or LV equal to pi L2. So this is equation number 1 and equation 2. Now divide equation 1 by equation 2. Divide the two equations, equation 1 by equation 2. We can get epsilon by V, which is equal to L1 by L2. So we know EMF epsilon equal to I into small r plus capital R, and V equal to IR from Ohm's law. So I should these values here. Epsilon equal to I into small r plus capital R by V equal to IR, which is equal to what? L1 by L2. So this I will get cancelled. Small r plus capital R by capital R, which is equal to L1 by L2. Separate the terms. Small r by capital R plus capital R by capital R, which is equal to L1 by L2. This capital R will get cancelled. We left with small r by capital R plus 1 equal to L1 by L2. Next, small r by capital R, which is equal to L1 by L2 minus 1. So I am sending this plus 1, this side becomes minus 1. I want a small r equal to capital R, you multiply there, capital R into L1 by L2 minus 1. So this is the internal resistance of the cell. If you want, you can write small r equal to capital R into, multiply this cross multiply here, L1 minus L2 by L2. So this is the internal resistance of the given primary cell. So in this way we can compare the EMF of the two cells, or else we can find the internal resistance of the given primary cell by using the potentiometer.